Mendelian Proportions in a Mixed Population by G. H. Hardy. From Discussion and Correspondence of Science NS, Volume 28, Number 706, July 10th, 1908. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Mendelian Proportions in a Mixed Population. To the Editor of Science, I am reluctant to intrude in a discussion concerning matters of which I have no expert knowledge, and I should have expected the very simple point which I wish to make to have been familiar to biologists. However, some remarks of Mr. Udny Yule, to which Mr. R. C. Punnett has called my attention, suggest that it may still be worth making. In the Proceedings of the Royal Society of Medicine, Volume 1, page 165, Mr. Yule is reported to have suggested, as a criticism of the Mendelian position, that if brachydactyly is dominant, in the course of time one would expect, in the absence of counteracting factors, to get 3 brachydactylous persons to 1 normal. It is not difficult to prove, however, that such an expectation would be quite groundless. Suppose that A is a pair of Mendelian characters, A being dominant, and that in any given generation the numbers of pure dominants, A, heterozygotes, A, and pure recessives, AA, are as P to 2Q to R. Finally, suppose that the numbers are fairly large, so that the mating may be regarded as random, that the sexes are evenly distributed among the 3 varieties, and that all are equally fertile. A little mathematics of the multiplication table type is enough to show that in the next generation the numbers will be as P plus Q squared to 2 times P plus Q times Q plus R to Q plus R squared, or as P1 to 2Q1 to R1, say. The interesting question is, in what circumstances will this distribution be the same as that in the generation before? It is easy to see that the condition for this is Q squared equals P times R. And since Q1 squared equals P1 R1, whatever the values of P, Q, and R may be, the distribution will in any case continue unchanged after the second generation. Suppose, to take a definite instance, that A is brachydactyly, and that we start from a population of pure brachydactylous and pure normal persons, say in the ratio of 1 to 10,000. Then P equals 1, Q equals 0, R equals 10,000, and P1 equals 1, Q1 equals 10,000, R1 equals 100 million. If brachydactyly is dominant, the proportion of brachydactylous persons in the second generation is 20,001 to 100,020,001, or practically 2 to 10,000, twice that in the first generation, and this proportion will afterwards have no tendency whatever to increase. If, on the other hand, brachydactyly were recessive, the proportion in the second generation would be 1 to 100,020,001, or practically 1 to 100 million, and this proportion would afterwards have no tendency to decrease. In a word, there is not the slightest foundation for the idea that a dominant character should show a tendency to spread over a whole population, or that a recessive should tend to die out. I ought perhaps to add a few words on the effect of the small deviations from the theoretical proportions, which will, of course, occur in every generation. Such a distribution as P1 to 2Q1 to R1, which satisfies the condition Q1 squared equals P1 times R1, we may call a stable distribution. In actual fact, we shall obtain in the second generation not P1 to 2Q1 to R1, but a slightly different distribution, P1 prime to 2Q1 prime to R1 prime, which is not stable. This should, according to theory, give us in the third generation a stable distribution P2 to 2Q2 to R2, also differing slightly from P1 to 2Q1 to R1, and so on. The sense in which the distribution P1 to 2Q1 to R1 is stable is this, that if we allow for the effect of casual deviations in any subsequent generation, we should, according to theory, obtain at the next generation a new stable distribution differing but slightly from the original distribution. I have, of course, considered only the very simplest hypotheses possible. Hypotheses other than that of purely random mating will give different results. And, of course, if, as appears to be the case sometimes, the character is not independent of that of sex, or has an influence on fertility, the whole question may be greatly complicated. But such complications seem to be irrelevant to the simple issue raised by Mr. Yule's remarks. G. H. Hardy, Trinity College, Cambridge, April 5, 1908. P.S. I understand from Mr. Punnett that he has submitted the substance of what I have said above to Mr. Yule, and that the latter would accept it as a satisfactory answer to the difficulty that he raised. The stability of the particular ratio 1 to 2 to 1 is recognized by Professor Carl Pearson, Philosophical Transactions of the Royal Society, A, Volume 203, page 60. End of Mendelian Proportions in a Mixed Population. Read by Avai.